This is day 2 of sequences, and I'd like you to just begin with these 2 starters. What are we doing from term to term to term? Adding 4. So you automatically write it down. Repetitive multiplying. Repetitive adding means multiplying. 4m. So I have the first term, so I can stick a 1 in there. Plus what will give me the term 5? 4 plus what gives me 5? Plus 1. So that's my rule. Let's make sure it works. When I put 2 in there, 4 times 2 plus 1, 9? Yep. How about when I put 4 in there? 4 times 4 plus 1, 17? That works. How about this one? Multiply by 3, multiply by 3. So I would take repetitive multiplying power. My power is always going to be n minus 1 times my first term. Should give me my rule. Now let's take a look at how we can generalize these rules. We call, when I repetitively add, this add-in a difference. So we're going to call that our D, a common difference D. Notice I have that as arithmetic. We either repetitively add or we repetitively multiply. What did you learn first in school? To add or to multiply? To add. And we have arithmetic and we have geometry. What did you learn first in school? Arithmetic. So would it make sense? An arithmetic sequence is repetitively adding. A geometric sequence is going to be repetitively multiplying. We call that repetitive adder a difference. So we're going to call that D. So what did we do? We took that D times n. And then we added some constant. So I'm going to put that in here. C is a constant. To get our rule. We call this repetitive multiplier a ratio in common. So we're going to call that R. So this is my R. What did we do to our rule? We took our ratio to the n minus 1 and multiplied it by our first term to get our term. So we can use these general formulas as we have been to generate any sequence. So let's see. Decide if it is arithmetic, geometric, or neither. And explain your reasoning. So, A, negative 10, negative 6, negative 2, 0, 2, 6, 10. What are you doing from negative 10 to negative 6? Adding 4. Negative 6 to negative 2. Adding 4. Negative 2 to 0. Adding 2. 0 to 2. Adding 2. 2 to 6. Adding 4. 6 to 10. Adding 4. So it is neither. Since I don't have a common difference, I have 2 of them, a difference of 4 and a difference of 2. It cannot be arithmetic because I need 1 common difference to be arithmetic. So let's try B. 4, negative 8, 16, negative 32. Times by negative 2, times by negative 2, times by negative 2. So it is geometric, since the ratio is a negative 2. Next one, 5, 6, whoops, 5. 11, 17, 23, 29. Add 6, add 6, add 6, add 6. So there's arithmetic because I have one difference of 6. 3, 4, 7, 11, 18. Neither. Because it's Fibonacci. Write the rule for the nth term. When your sequence is 32, 47, 62, 77, what are you doing? Adding 15, adding 15, adding 15. So I would write the rule is going to be 15n. When you put a 1 in that n spot, do you have the first term? Yeah. So 15 times 1 plus what will give me the term 32? 15 plus what is 32? 17. It also says this. What does A sub 12 mean? To find the 12th term. So plug a 12 into your equation. 15 times 12 plus 17. 197. Now it says we have an arithmetic sequence. What does this mean? The 8th one is 50. What does this mean? I'm adding 0.25 every time. So write your rule. Adding 0.25, 25n. Then you put a 1 in here. No, I don't have the first one. You put a 2 in. No, I don't have the second one. I have the 8th one, so I need to put an 8 in. Plus what will give me the term 50. A fourth of 8. It's 2 plus what gives me 50. 48. So then if I graph it, the first one, 0.25 plus 48 is 48.25. So I'm going to put a break in my graph. Start at 48, count by 0.25. 48.25, 0.5, 0.75, 49, 49.25, 0.5, 0.75, 50. What do I have? Linear. Is this a linear expression? Yes. That becomes very important to know. Arithmetics are linear. I'm going to go back here. Our expression was an equals dn plus c. A linear is y equals mx plus b. Notice y, my range, is the same as my terms, a sub n. D, the difference, is the same as my slope. The position is the same as my x, my domains. D is the same as slope. Now let's use that to do this one. What do you have? The fifth term is 10. The 30th one is 1/10. So write a rule. dn plus c. Well, d is the same as slope. How do you find slope? The difference of my y's, which are my a sub n's, over the difference of my x's, which are my n's. 100 by 25 is 4. My difference is 4. So I can put a sub n equals 4n. And I put a 1 in here. Do you have the first one? No. Do you have the second? No. I have the fifth. So 4 times 5 plus what gives you the term of 10? 20 plus what gives you 10? Negative 10. Part B says, what value of n is the term negative 2? Where do I put the negative 2 in this expression? A sub n equals 4n minus 10. Add 10. 8 equals 4n. n equals 2. The second term is a negative 2. Let's look at a real life situation. A construction company is laying natural gas pipeline. Several sections of pipe have been laid in a pile at the construction site. There are 12 sections of pipe in the bottom row. Each row has one less pipe than the row below. There are 8 rows of pipe. So here, in this 8th row, I have 12 sections. Then in the 7th row, I would have 11. Then in the 6th, I would have 10, all the way up to the first row. So what's my pattern coming from row to row to row? Add 1, add 1. So for my rule, I would write a sub n equals 1n. Can I put a 1 in here? Well, I have the first. I have the 8, so I'm going to put an 8 in there. 1 times 8 plus what gives me my term of 12? 4. Which row has 6 pipe sections? 6 pipe sections, is that the term or the position? The term. So 6 equals n plus 4. Subtract 4. N equals 2. Row 2 has 6 sections of pipe. How about this situation? Write the rule for the arithmetic sequence where a sub 1 is 15 and the difference is 5. Explicit. Let's see what's happening. First term is 15. Difference of 5 means adding 5 gives me the second term. Adding 5, etc., etc. So 5n could be my term. Then I put 1 in there. Plus what gives me 15. Subtract 5. 10. Plus 10. Explicitly, 5n plus 10. Recursively, what am I doing? Adding 5 to the previous term, beginning with 15. Write the rule for the nth term of the sequence 5, 2, 0.8, 0.32. Can you see what you're doing? 5 to 2. Can't see there. Can you see from 2 to 0.8? Timesing by 0.4. Timesing by 0.4. Is 5 times 0.4 2? Yeah. So, my rule, multiply by 0.4 repetitively means power times the first term. What's this mean? Find the eighth term. 5 times 0.4 to the 8 minus 1. 5 times 0.4 to the 7. .008 192. Graph. First, second, third, fourth, fifth, sixth, seventh, eighth. First was 5. 5, 4, 3, 2, 1. One is 5. Second one is 2. Third one is 0.8. Fourth one, 0.3. Eighth one, 0.08. What's this making? A J curve, a decay. Is that a ratio of decay? Let's see this. So let's look at some geometric. The fourth term of the geometric is 3. The ratio is 3. What's that mean? I'm multiplying by 3 each time. Write your rule. Geometric. First term. Do you have it? Nope. Times the ratio. Do you have that? Yeah, multiply by 3. To the end. What position? 4 minus 1 should equal the term, which was 3. Well, this is 3 equals a sub 1 times 3 to the third. What is 3 to the third? 27. Divide by 27. 3 divided by 27 is 1/9. First term is 1/9. So I can come back here. Rule is first term times the ratio to the n minus 1. How about this time? Third term's 24. Eighth one's 58, 32. Since it's geometric, I know I need a ratio. So I'm just going to plug it into the formula. A1 times R to the n minus 1. I'm going to start with a bigger number. So 58, 32 equals first term, I don't have it, times the ratio, I don't have it, to the n, 8 minus 1. Now I'm going to set the next equation up as a ratio, just like I did when I did exponentials. Exponentials are geometric. I'm going to set the next equation. 24 equals first term times ratio to the n, 3 minus 1. 58, 32 divided by 24. 243 equals a sum 1's reduce r to the 7 divided by r squared is r to the 5th. So I'm going to have to fifth root. 3 equals r. Now I need a sub 1. Which equation do you want to plug it back into? The smaller one. 24 equals a sub 1 times r, which is 3, squared. 3 squared is 9. Divided by 9. 3 goes into both those? 8/3. Now I have my a sum 1. So I can plug it back into my original formula. The rule is first term, 8/3, times the ratio, 3, raised to the n minus 1. Let's write a few more recursive rules. What are you doing from term to term to term? 21 to 17 to 13 to 9 to 5. Adding 4. Oops, subtracting 4. Subtracting 4, subtracting 4, subtracting 4. So, I am subtracting 4 from the previous term, beginning with 21. How about here? 2 to 6 to 18 to 54 to 162. Times by 3. So, times the previous term by 3. Beginning with 2. Now, a couple real life situations, and we can call it a day. You're going to buy a new car for $25,000. The car decreases in value by 16% each year. Write your rule. Make some math. Equals. So what's happening in this sequence? In your first year, you have how much? $25,000 worth. What do I have to do to get my second year? 16% decrease. Decrease from 100%. 100% minus 16% gives me 84%. So if I multiply by 0.84, I should get my second year. And continually multiply by 0.84. So it is geometric. First term, 25,000, times my multiplier, 0.84, raised to the n minus 1. Now part B says, well, when will your car be 10,455? Is 10,455 a sub n or n? A sub n. 10,455 equals 25,000 times 0.84 and n minus 1. Divide by 25,000. Let's see. One to the end. 10455 divided by 251. 0.41822. Now what? Log both sides because you can never get 0.481822 to be 0.84. So log 0.41822 equals log 0.84. And our exponent moves to the front to multiply, so multiply n minus 1 times log 0.84. Divide by log 0.84. And then I'm going to have to add 1. And let me get 6. 6 years for the car to be worth 10,155 years. And one last one. You just received a job where you made $25,000. By signing your contract today, you're guaranteed at least a 6% annual raise. What will you make in your 7th year on the job? So my first year, I'll make 25,000. What will I make my second? 6% raise. So I'm going to multiply by 1.06. 100% plus 6%. So I have geometric. Base of n will equal beginning term, 25,000, times my ratio, 1.06, raised to the n minus 1. My n is 7. 25,000. 1.06. 7 minus 1. 25,000. Times 1.06 to the 6. $35,462.98. And that should help you get through your sequences.